This is a presentation about matter. You've probably heard of matter before and may even be thinking at the back of your mind some middle school definition of what matter is. So let's get that out in the open anyways. It's something that has mass and volume. Matter comes in two forms. You can either have a pure substance, which contains one type of matter, or you can have a mixture which contains two or more types of matter. One thing I'm going to mention about the pure substances, it seems like my direction that I'm going with this is not following exactly, but anyways, for a pure substance, we would know it's a pure substance because it can't be separated into simpler substances by methods like filtration or evaporation, where certainly, pure substances can be broken down if you really smash the living heck out of them. But by common methods that we'd find in a general chem laboratory, you can't break them down into simpler substances. Mixtures, as I mentioned, are made out of two or more types of matter. There's no physical bonds between these holding these together. So they can be separated by simple methods like filtration or evaporation. So let's talk about pure substances. Pure substances can basically be one of two things. They can be an element. If it's an element, then it only contains one type of atom. If it's a compound, it's got two or more types of atom. This time, these are going to be bonded together. So these atoms can't be pulled apart from one another easily. So examples of an element would be basically anything that's on the periodic table: hydrogen, carbon, uranium, iron, copper, zinc, sodium. All of those would be elements. Compounds, on the other hand, have two or more types of element in them, and they usually have, or they always have, a defined chemical formula. Things that you might be familiar with would be things like water, sodium chloride, carbon dioxide. Those would all qualify as compounds. We also have mixtures to deal with. We won't spend a lot of time dealing with mixtures, although we will talk about solutions later on in the chapter. Mixtures come in a variety of different types. There are heterogeneous mixtures, and you can see a distinction between the solvent and the solute. So the majority substance and the minority substance, you can see a difference between those. You can easily pick those out. Coming up with chemical examples that you'd be familiar with are probably a little bit more difficult, but something like a chocolate chip cookie would be a good example of a heterogeneous mixture, or concrete, that you can see that there's a matrix that smaller particles are suspended in. There are homogeneous mixtures, and homogeneous mixtures are mixtures where you can't distinguish where the solute and the solvent are. It's homogeneous across that. Within homogeneous mixtures, we have a variety as well. There are mixtures that we call solutions, and solutions are transparent. And if we shine light through them, it doesn't scatter the light. A good example of a solution would be sugar dissolved in water or salt dissolved in water. Unless you taste it, you wouldn't know that there was sugar or salt dissolved in that water. Suspensions, on the other hand, tend to be cloudy mixtures, and if you shine light through them, the light will be scattered. An example of a mixture might be something like oil and water. Typically, suspensions will separate into their individual phases, so they may settle to the bottom, or in the case of oil, it would rise to the top and form a separate layer from the water. Colloids, on the other hand, are like suspensions in that they scatter light, but they don't separate. So milk would be an example of a suspension. If you look down really close under a microscope, there's little globules of fat suspended in this kind of aqueous matrix. So it's mostly water, but there are some fat particles and other things that are dissolved in that type of mixture. And I think we're done with this. I keep on forgetting how many slides I have in each of these. So let's see. I'm going to click, and if it's the end, then it's the end.